Let's just talk through a couple of details, because for the most part, y'all are solving this well. For the most part, we're solving this well. The only thing that I would remind y'all is looking at the square root of negative 44. Remember, if it's irrational, which this isn't really irrational, what kind of number would this end up being? Square root of a negative. There's an I, so it's going to be called imaginary. Remember, if there's an I, it's going to be what? Imaginary. Now, if I have this just the square root of 44, that would be what? Irrational, right? Just the square root of 44 would be irrational, but that's not what we have. Square root of negative 44. Regardless, though, if I'm going to simplify a radical, I need to find, at least with a square root, I need to find perfect squares. And I will point that out, with a square root, I would need to find perfect squares. With a cube root, I need to find perfect cubes. Fourth root, perfect, whatever we would call that. But we're not going to stress that right now. Right here, a lot of us started picking up, right? That's a perfect square, isn't it?
Yes.
So 4 times 11 times
Negative 1.
And I will point this out. If I have a square root of negative, you know what factor I always want?
Negative. Oh.
Negative 1. Guys, I need y'all to notice, like, if I have the square root of a negative, I always want to factor a negative 1 because that's going to give me what number? I.
Yes, sir.
Remember that, square root of negative 1. If I have the square root of a negative, I always want to factor a negative 1 out. And so I have 3 factors. How many radicals or square roots do I want? How many factors do I have? I have
1, 2, 3.
So how many radicals do I want?
3.
3. Now, I may simplify it so I don't have 3 at the end. In fact, I will. But each factor becomes its own square root. Cameron was earlier seeing it right away from here and jumping to the end. That's okay, but I will caution you, I would always write it out this way. This is something where students who do this each time more consistently get it right. Let me say it that way. Can I take the square root of 4?
Yes.
What is it?
2.
Can I take the square root of 11?
No.
So why not? Because it is,
Not a perfect.
yeah? So what kind of number would that be? Starts with an odd? Irrational, right? So that would be irrational. Square root of negative 1 is? And don't forget, traditionally we put that I at the end there. So, right here, hey guys, right here. So I'm rewriting it this way. And so what I would point out is, in Mathia, they forced you to separate it into 2 values. I don't require that. I don't require it. You can leave it like the plus or minus like this. The one thing I will say is you do need to simplify. Literally one of your skills on the proficiency scales is simplifying radicals like this. So I do need you to simplify that radical. And you could technically leave it here, but I will point out, can't I divide everything here by a 2?
Yeah.
So you could further simplify this. Division has a distributive property, just like multiplication. So I'm just rewriting this where everything's divided by 2. And what's 2 divided by 2?
1.
1.
Plus or minus. So remember, that's 1. That's 1. So what am I still left with?
11.
Square root of 11.
Oh,
11.
Square root of 11 I. Those would be my roots or my zeros. One thing I will point out about this, and I need y'all to hear me on this, if I were to graph this function right here, if I were to graph this, would I see those zeros on the graph?
Oh, yes. Pretty sure.
Pretty sure?
Yes.
Anybody want to add on to or push back on that? If I were to graph this function, would I see these zeros or these roots on the graph? Probably.
No, it's imaginary.
Say that one more time.
It's imaginary.
These are imaginary, right? Remember, what's going to happen graphically because my roots are imaginary? It's not going to intersect something.
The x-axis.
It's not going to intersect the x-axis. Let's check that really quickly before we move on with today's lesson. So, graph, what was it, 2x, nope, x squared minus 2x plus 12?
Yes.
Man, I don't even see it.
We gotta zoom out.
Where's that?
Go to menu. Make our-
Hey, yeah. Hit that menu button. Oh, never mind.
So you could do that, but I will point out, notice, what was my y-intercept, guys? What was my
Oh,
y-intercept?
12.
12, and it was concave up, right?
Yes.
Is it intersecting the x-axis anywhere?
No.
The x-axis is way down here, right? We got imaginary roots because, does anyone remember what degree this function is? Or this equation? It's degree what?
This is standard.
Someone said, I thought.
Standard degree.
No, what degree is this polynomial?
Oh, the third.
Concave up.
It's not
It's
cubic?
not a degree. No, it's not cubic. In order for it to be cubic, it's gotta be x what?
Third to the third.
X
Oh,
to the third. You see x cubed here?
no.
No, it's x
Squared.
squared. So you know what degree it is?
Squared. 2. Degree
Degree
2.
2.
Yeah.
Okay? We'll talk more about this, I guess, today. But it's x squared, it's degree 2. We'll talk more about that. But that means it has how many zeros?
2.
Does anyone remember? I think you can make better decisions. Thank you.
Make better decisions.
Come on, man.
It's gonna have how many zeros?
2.
Degree 2, or it's gonna have 2
Yeah.
based on a theorem. Anybody remember that name of that theorem?
Oh,
It
the theorem of algebra.
is what type of theorem of algebra?
The-
It is
the-
Diagram theory.
Right.
starts with an F. Alright, I couldn't remember if we talked about it or not. This one's on me. Alright, I'm gonna show it to y'all in just a second. Alright, I'm gonna show it to you just 1 second.
What does it end with? It start with F and end with
It's
what?
pretty fundamental to algebra.
Function?
It's a theorem that's pretty fundamental to algebra. Fundamental.
The fundamental theorem of algebra.
yeah.
Oh, yeah. Okay.
Wait, fundamental
fundamental
theorem of algebra. I mentioned it last week.
Yeah.
A little bit.
He mentioned
Alright.
just a little.
Hopefully you talked about it in Algebra 1, but I don't know about that. Alright, so here's what we're doing today. We're going to quickly do a Mathematician Monday. We're going to do some more about complex numbers. Really quickly, sorry, I got an unexpected opportunity this weekend to go take my dad to the football game, so I did not have time to do anything Saturday with
Yay.
assessments or grades. It was a fun time, but
Wait.
I will make sure, sir.
You sure? Because my grade went up.
So, sorry,
grade
let
was at 2
me
and 1 o'clock in the
restate that. Restate that.
Yeah.
I got some stuff with grades done yesterday. What I
Okay.
meant to say was, I did not get anything done with Mathia, right?
Okay.
So I will be putting those Mathia grades in from the e-learning day a week and a half ago.
I still got a chance to get 60 points, right?
Say again.
Like 60. I still got a chance to get like 60 or 50 points.
Wait, make sure.
Say it again.
I still got like a chance to get like 60 or 50 points, right?
Yes.
Okay.
Have you not done them yet? Oh my gosh, come on. Actually, I will say a whole lot of us have not done that e-learning assignment yet. Still need to get some credit.
We don't never tell you when you done.
So you did?
I'd be confused.
I thought it was gonna
there
be
for like 3
Yeah,
hours.
if you done, it'll tell you. If you mastered it, it'll tell you. So, hey, listen, I will get those upgraded or updated today.
Yes.
Really quickly, bathroom note. I am sorry to inform some of y'all, but we are going to the bathroom entirely too much. If it's at the very beginning of class, I'll let it go. However, from here on out, you got 3 bathroom visits for the 9 weeks.
Oh,
Have that.
Mr. Kennedy, don't tell me you becoming one of them people. Don't
Now-
tell me you becoming
Hey,
one of them
Can't
teachers.
stand
Listen.
teachers like that, bro. How you
Hey.
tell somebody when to urinate?
I feel like in this classroom, we're taking advantage of me letting you use the restroom, and we're going in all the time. Once again, if you need to go at the beginning of class, early on, I won't count that one against you, okay? Y'all have a chance on the way to lunch, on the way back from lunch, and I'm gonna let you go at the very beginning of class. So, you have opportunities. Outside of that, you're gonna have 3 chances to go to the bathroom. I will mark it in my attendance book. Sir,
Complain about it.
sure.
Is it no tardy coming back?
The bathroom be too bad, so
Okay.
I be late.
I'll treat it like I do at the beginning of the block. So if you have to, if it's packed in there, come in, let me know, quickly use the restroom, because I get that coming back from lunch. Okay,
Y'all, you don't like, it's no tardies coming back from lunch?
no, there are tardies coming back from lunch.
Oh, okay.
Yes.
Then I ain't gonna be able to stop in the bathroom then.
When you just
Just
do
tell
you
J Mike.
Oh, shoot, my fault.
Okay, thank you. All right. So we got some complex numbers today. We got to get through this. We got to demonstrate understanding.
Whoa, win.
Today,
What?
I told y'all that Friday. We got a test on Wednesday.
I ain't gonna lie.
Be on Tuesday.
You back?
Y'all, I told you.
Back to back.
Hey,
No route.
there's
No
a
route.
demonstrate your understanding, which is a check on your understanding to know what to improve before the test. Remember,
My grade just went up.
hey, listen, your demonstrate understanding grades can
Yes.
always be replaced by the test grades.
Wait, huh?
Yo, demonstrate your
Demonstrate
understanding grade.
understandings are checks on the way to get to the test.
Yes.
If on those same skills you do better on the test, I replace your demonstrate understanding grades because you've shown me higher level of understanding. So, lots of us in this class have had our demonstrated understanding grades increase because of that. On top of the fact, demonstrated understanding grades are only 10% of your overall
You're right,
grade
I
in this
did
class.
see, I got
Okay.
it.
And it'd be better for me to give you a demonstrated understanding to give you feedback before the test so that you don't get to the test and be like, what the frick just happened?
I ain't gonna
We
lie.
already do some of that,
Stop.
even with me giving demonstrated understanding.
Them demonstrate your understanding be cooked.
All that being said, we're gonna quickly do Mathematician Monday, and then we're gonna get back to the math. Brady, can you hit the lights for me? So if you remember last week with Dr. Velez, I told you that I was really impressed by him, so I was gonna spend 2 weeks on him. I gave you part of the story last week. Here's some of the other things. So I wanted to get into some of the math, so I didn't get all the stuff from his background. Remember, we talked about the fact that he came from the poorest of the poor. He came from a family where they had to rent out part of their house, so they were only living in 2 of the rooms in his house. And he was still able to be successful. And one of the things I want to point out right here is when he grew up, it was one of the worst times for Mexican Americans in terms of racism. I know that we have a different level of racism today in different places, but he grew up in Texas, right? And so what he felt like was that schools were trying to make him into a white boy. And his response was that he fiercely embraced his Mexican culture. And I love that. Listen, don't let someone tell you how to feel about your culture, about your history, things like that. But I will point out, always be aware that in every culture there's good and there's bad. And that's one thing that he pushed back against was the bad elements of his culture, but he embraced the beauty and the vibrancy of the Mexican American culture. And so that's what I want to encourage you from pulling from him, right? It's never okay to be thought of as a second-class citizen. That's never an acceptable thing. However, he made a difference, and he didn't just take it. Push back on injustice, please. Fight for better and fight for more, because that's exactly what Dr. Velez did. Coming from absolute poverty to making good money as with a doctorate in mathematics and working in universities, things like that. Don't let your past define you. Look for the good, look for the bad, push back against those systems that are unjust. On top of that, I want to point this out, right? So this is a guy who now has a doctorate in mathematics. One, it actually is really hard to be in graduate school at the same time as getting married and having children. Heck, it's hard enough just having a child as is because you have to completely change your priorities. Like, I don't have as much time to grade and to do work as I used to because I got to pour a lot of time and effort into loving Alex and making sure that he grows and learns. And so it takes a lot of time and effort. There's always things that are going to be going on in life outside. On the day that our daughter was born, I did not turn in a good homework set for my algebra class. The next class day, the instructor walked into the classroom and handed back the homework. Wadded it up in a ball, threw it at me across the room and yelled, "You will never be a mathematician." How often do we have things that go on outside the classroom that affect our ability to be successful inside the classroom? A lot. I get it. Okay? However, he did not let this define him or destroy him. What I want to encourage you out of this story is that the past doesn't have to define you, that you can be successful mathematically and that it's good. You don't need to get a doctorate in mathematics. That's not for everybody. Heck, my brother didn't even go to college. It's not for everybody. And I think that was the best decision for him. But I do want to emphasize and remind you that your past doesn't have to define you and that anyone can be successful mathematically. And so, the other thing is family's important. I do know that sometimes we come from broken families, but find what your family is, whether it's blood, whether it's not. But when it comes to finding your families, make sure that that family is love-centered and challenging each other to be better. Don't find somebody who lets you stay stagnant and not grow. He fell in love with his family. He loves his child, he loves his wife, and so he was constantly trying to provide better for his family. And that's something huge to hold on to. So, don't let your past define you. Last piece for Dr. Velez and for me, I absolutely loved what he talked about when it came to research. He never really had a research program. One of his best research tools was the question, hey, what are you working on? And just asking what other people are thinking about and doing and learning from other people and going deeper. And what he said here was, of course, I failed more often than I succeeded. I found out that I was not clever enough for this research style, and that does not mean I was a failure. I earned a PhD in number theory and in the process participated in the mathematical adventures of a community. Okay? Failing does not mean you're a failure. It doesn't. A lot of times I feel like school does a disservice to students because either you succeed right away or you're a failure, and that's just not the truth. People who are successful are the ones who take the struggle on the nose and they overcome. He wasn't ever a failure because he kept going. It can sound like a cliche at times, but it's very accurate that 1 instance, 5 instances, 20 instances of failure does not make you a failure. Do you keep getting back up and working to overcome it? Because hard work pays off, both in the classroom, both in work, and on the football field, on the basketball court. Doesn't matter where you are. We don't take failure and just give up on ourselves. And I'm not going to give up on any of you. It's time to grow and to learn, and you're capable of it. Your past does not have to define you. So let's fight for better. So, all that being said, foundation, right? We started talking about these complex numbers last week. Classifying numbers over the real number system. What were the types of numbers that we had studied, hopefully, in previous math classes? You might have talked about, okay, so whole, natural, so we hadn't talked about complex yet in previous classes. Maybe in Algebra 1, but not usually. So integers, so whole, natural, integers, rational and irrational, and real numbers. Those aren't numbers, those are operations, or the symbols. Okay? And we're going to be getting into that number I. Okay? And that's building us up to being ready for this part of complex numbers. Now, the fundamental theorem of algebra, this is what we were referring to earlier. Okay? So, really quickly, I want to establish this. I thought I had talked about this last week, but if not, my bad. So this is a degree 2 polynomial. This is a degree 3 polynomial. I'm telling you something. Chill. You got this. This is a degree 7 polynomial. What do I mean by degree? Can you hit the lights for me, Greg?
The amount of zeros it's going to have.
So 100%, but that's not based on these equations. Based on these equations, what do I mean by a degree?
Well, I think about the degree. When I see like a degree 3, I see like an x3, and I see degree 7.
So you see x cubed and you see x
7. That's
7.
like degree 7.
And x squared. And what did you say, Dewan? Your degree is your highest power. And say that again, J. Mike. What did you say about the zeros?
the amount of zeros it's gonna have is gonna be based off the exponent,
So, and not just any old exponent, which exponent?
the highest one.
So how many zeros is this function gonna have?
6,
7 zeros. How many zeros is this function gonna have?
3,
3. How many is this one gonna have?
2.
So, I will point out we have to know standard versus factored form is what next unit's gonna be all about. But the fundamental theorem of algebra just says this. An nth degree polynomial has n zeros. And when we say nth degree, that means it can be any exponent, right? It's just the highest power. That's a 7th degree, nth degree, 7th degree, so it has 7 zeros. They could be imaginary, they can be real, they can have what's called a multiplicity that we'll study next unit. It just has that many zeros. Alright. Nope. Nope. We already did this in this class, so I had to change things up for 3rd versus 4th, but we already did this page last week, right? How do we know graphically right here that this had imaginary zeros? Does not intersect the x-axis. That's it, right? It has imaginary zeros. If it's not intersecting the x-axis, one thing I want to remind you is this. Yes, I is equal to what?
1, -1. What is square root?
Square root of -1. Now remember, I is equal to the square root of -1 because we defined I squared as what? So this came first. Don't forget, this was first. And because I squared is -1, we now know I is the square root of -1. So don't forget that I squared is equal to -1 was first. Already talked about that. Okay. So we actually already did all of these things. So we technically did not do this one last week. However, didn't we just do a standard form with imaginary zeros to start? So I'm going to skip that part, okay? We just did one of those. Don't need to stress all these details. Alright, this is where we pick up. So, we're talking about classifying numbers here. Alright? I know we talked last week, imaginary numbers, what do they have to have? I. We talked about natural numbers, right?
They have the like regular number. Just regular.
What do you mean?
Like 1, 2, 3, 4,
1, 2, 3. So where we naturally start counting is at
1.
So 1, 2, 3, 4. Does it stop?
Nope, it continues.
Continues forever. So how is the whole number set different? It starts at 0, 1, 2, 3. Okay. Integers. So is the whole numbers and their opposites. Okay. So what's the opposite of 1? Opposite of 2? Opposite of 3? And it keeps going. Okay. Now, one thing I will point out is you can. Yep, 97. You can just write the symbols if you want, or you can write out the words. It's your choice. But you do need to be able to justify these things. Now, when's it going to be a real number? When's it going to be a real number?
Equal 0.
Okay, so when there is not a what? There's not an... As long as there's not an I, it's going to be what? Real, right? So as long as there's no I, and if it's real or imaginary, it's complex. Now, rational. How much did we talk about rational last week? Tiny white bit.
Some of them are the fraction part.
Okay, we talked. Okay, so we did mention that in this class. Remember, the first half of rational is. So it's a ratio of what? Not just any old numbers. Integers. If it can be written as a ratio of integers, it's rational. Notice, that's when the decimal either terminates or the decimal... Hey guys. Decimal either terminates or it repeats. It's not just that it doesn't, it can repeat. Because with irrational numbers, that decimal does not terminate, and you know what it also doesn't do? It doesn't repeat. So, your irrational numbers are the numbers that do not terminate as a decimal and do not repeat. Notice, most irrational numbers are going to be, most of the ones you deal with are square roots and cube roots of non-perfect squares, non-perfect cubes, the whole nine. The last thing I want to point out, symbol-wise, to help this make sense, this is saying what? What's this R stand for?
Ratio.
Real. Regular is not a type of number.
So basically, it's a fraction.
Well, it can be written as a fraction, but remember that either means that's the term nature repeats. Hey guys, what does R stand for? Real. Hey, Mike. Ladies and the aces. So my irrational are all my real numbers, but taking away what? The rational. So it's the real without the rational. That's what this symbol is saying. Now, can you also just say irrational?
Yes.
100%. But if you want to use those symbols, when we say real minus q, or r minus q, it's the reals without the rationals. Now, at this point, vertical surfaces for the last few minutes before we go to lunch.
I don't want to look at my verticals are for you.
Wait, aren't there a set of questions? Yes. Page 98, I want you to look at A, B, C, D, E, and F and identify every number or every set that number exists in. For example, A has the number 3. What type of number is 3? Okay, is 3 a real number?
Yes.
Okay, is it anything
A
else?
whole number?
Is it a whole?
Yes. A natural number?
For sure.
Yes. An integer?
Yeah, I
Yes.
did it.
And complex?
So, I want y'all to notice, you said it's a natural number, right?
Yes.
So it's also a whole number, so it's also a
Rational? So it's a real? My fault.
okay? Remember, you can rewrite 3 as 3 divided by 1, or 6 divided by 2, etc. So let's get to our vertical surfaces and start sorting with B. So identify every set, it's page 98. Page 98,
Already hit it.
Mr. Dewan, to the section that's on the imaginary numbers if they want to work on it to prepare for demonstrate understanding. The only thing that was not in Mathia is classifying numbers like this. But I gave you a Frere model on that specifically. I would practice doing this. It is on your demonstrate understanding. With where we are, demonstrate understanding is gonna have to be tomorrow to start class.
We just started?
Demonstrate understanding has to be tomorrow to start class. We'll go over it immediately and I'll have to give it back to you to study for your test on Wednesday.
Okay.
That's the plan. Now, so let's talk about a couple of key ones right here. Hey guys,
Let me sit down, relax.
square root of 7. As soon as I see that square root,
Yes.
what am I thinking?
Complex.
I'm finna lose my.
Because every number is
I'm
complex.
finna lose my mind.
So I will say this, I'm going to talk about that in a second. When I see the square root, there's something else I'm immediately thinking. Not imaginary, irrational. I will point this out, this is not going to be imaginary. Why is the square root of 7 not imaginary? It's not the square root of a negative. Huh? We'll talk about that in a second. So hold on. Listen, the reason why I would never say imaginary here
Yes.
is because there's no I and there's no square root of a negative. So if it doesn't have a square root of a negative, it doesn't have an I, it's not imaginary. J. Mike, Taj, I need you right here to focus. So, now we'll point this out. Square root of 16, what does that equal? Because that's a perfect square. Okay. Square root of 16 is 4 because that's a perfect square. Is 7 a perfect square?
No.
No. So it is going to be
Irrational.
square roots of non-perfect squares are irrational. They always will be. That decimal will not terminate or repeat. Remember, if that decimal can terminate or if that decimal repeats, it's going to be what? So which examples do you see up here? So I'm gonna come back to B in a second. Which of these have repeating or terminating decimals?
D.
D.
Yes.
You see that 4, 5 that's repeating?
Yeah.
That's rational. That means I could have written it as a ratio of integers. Okay? Anyone see another one that would be rational?
Oh, rational? No, not real.
There's one more.
What?
YE.
Oh.
It's now be careful. Rational or irrational?
I don't know. What is that?
That's
The
rational.
number pi?
That's rational.
Oh. Rational? Hey, you got lost me.
Okay, so let me point this out.
Wait, no, it's irrational. It don't repeat.
I would say pi is probably the most famous irrational number that there is. 3.14159, yada, yada, yada. That decimal never terminates. It never repeats. And so if that's irrational, is this number going to be rational or irrational? It's going to be irrational. Remember, I said it has to be a ratio of, starts with an I, integers.
Integer.
To be a rational number, it has to be a ratio of integers.
Right.
If it's not an integer, all that goes out the window. Square root of 7 divided by 3. Is the square root of 7 rational or irrational?
Irrational.
That's irrational. So this overall number is going to be,
Irrational.
to be rational, it has to be a ratio of
Integers.
integers. To be rational, it has to be a ratio of integers. Now, one thing I will point out here is, I want everyone to hopefully have their, this sheet out. And if you don't, get next to someone who
I
does,
do. Get next to my sheet.
because I want you to note, so get next to someone who has it,
Get your sheet. Yes, close that package.
alright? So get next to someone who has it. Now, hey ladies and gentlemen, hey, pause. I want you to look where it says irrational. First off, is there anything underneath that irrational section? No. So, if you look under irrational, is there anything below it? No. But an irrational number, look above irrational. Is irrational a real number? Yes. There is no I there, so it is real. Is there anything above real?
Yes.
What is it?
Complex.
It's also complex.
I said that.
Thank you. I'm going to talk about that in a second, Dewan. I never said you were wrong. I said I wanted to talk about that in a second. Get out your feelings. All right.
The one being his feelings?
So, he's always in his feelings. His whole note to me last week on his reflection was, Mr. Kenny, stop glazing. I was like, you didn't say it, dog. Don't worry about it. So look, all right? Actually, right here. D, this is a rational number. I want you to look at rational. Is there anything below rational?
Yes.
What is it?
Integer.
Integer. Now, so pause for a second. Is this an integer?
Yes. No.
I don't know.
Yeah.
No.
What is it?
Remember, the integers, do the integers have any decimals or parts of a whole number?
No.
So is it an integer?
No.
No. Is it a whole number?
80.
Yes. Oh, you talking about that number?
The
Oh,
45.
no, not whole numbers. Not whole numbers.
But
It's
the
5.45 repeating.
No.
So no. Okay? It's not an integer, it's not a whole number, it's not a natural number, but look above rational.
Yes.
What's above rational?
Real.
Is this a real number?
Yes.
Yeah, there's no I, that's a real number, 100%. Look above real. Is it complex?
Yes.
Yes. So rational, real, and complex. Okay? So I want you to hear me on this. If you learn that chart and you find the most specific one that it fits into, you can just trace it all the way up from there. So for the example, for -7, what is the most specific category that -7 fits into? Like the furthest down the tree. What does it fit into?
It's an integer.
Is it an integer?
Yes.
Okay, so let's look below it. Is it a whole number?
No.
No. Okay, so not a whole number, but it is an integer.
Yes.
Now trace it up. What's above integer?
Rational.
Rational. So is this a rational number? Yes. What's above rational? Real. Is this a real number?
Yes.
Is it a complex number?
Yeah.
So Dewan, what type of number is every number we will study? Guys, I need y'all to notice. Every number is complex.
Every single number.
Every number we have is complex. And after being complex, it's either got to be one of two things. It's either going to be,
Rational or irrational?
remember, rational and irrational are only for the reals, right? So a complex number is either going to be real or imaginary. Every number has at least two categories because they're all going to be complex. And then they're either going to be real or imaginary. Thanks, I appreciate it. Look guys, complex at the top. From complex, it's either going to be real or it's going to be imaginary. Guys, notice if it's imaginary, is there anything below that? No. If it is real, then it's either going to be rational or irrational. So if it's real, it's got at least three categories. But if it's irrational, could it be anything below?
No.
Okay, so we need to know these things. Make sure you have notes on your sheet about what the complex number, well, first off, every number we study is what? Every number we got is complex, right? How do we know when it's real?
Oh, yeah.
Every number is complex. Hey guys,
All these up here, they were complex.
how do, yes, all of them are complex.
Okay.
Square root of, guys, if you have a square root of -1 or you have an I, what is it going to be? Imaginary, right? And so if it doesn't have the square root of -1, if it doesn't have the I, what's it going to be? You need to notice that. You need to make a note of that to yourself, right? If there's an I, it's imaginary. If there's no I, it is real. Simplest detail to get there. You can explain that, by the way. Those are things to explain. What are the most common set of irrational numbers you're going to deal with? The square roots. The square roots of imperfect squares. So make sure you have notes. We should have all these things there. But we got to continue with the last 24 minutes we have of class. So take a couple of minutes. I'm going to give you 2 minutes to write out whatever notes you need to about this information. What I will remind you of is, okay, look, there is a whole section on a Frere model about classifying complex numbers if you don't have this sheet from the book. Your 2 minutes starts now. Not to this class sometimes. All right. Really quickly, I just want to point this out. Okay? I have provided, hey guys, right here. I have provided some check your understanding with classifying complex numbers. I would highly recommend doing these. Hear me clearly on this though. Dewan, chill. Amaya, chill. She's leaning towards you to hear what you're saying, dude. That's how I feel too. All right. So look, my point is, what I will say is, I will not put anything on demonstrate understandings or test beyond the medium section. Okay? For classifying the numbers. The spicy, if you can do the spicy, you're set. Okay? But these are practice problems. The answers are on the back side. I used the symbols instead of the words, but be aware that that's some practice that I would do. I did not justify them. I just put the answer. But be prepared to explain your why. Last week. You ain't even looked.
Hey, look, it's sexy red. It's sexy.
Well, this is your problem. Okay. I need us to get some practice in with concepts like this on page 99, simplifying complex radicals or imaginary
Look at me all of a
radicals. So
sudden.
page 99.
Y'all looked at me all of a sudden.
I'm gonna give y'all
Are you over there
6. Yeah. Hey, ladies and gentlemen, you've got 6 minutes to do as many of A through D as you can. So page 99. At your vertical surfaces, 6 minutes to do as many of A through D as possible. Let's go. 6 minutes. Whoa.
Sometimes you gotta let it out.
I can't even see.
Get this again. First off, what is the square root of negative 1?
I.
Square root of negative 1. I. Hey, go on.
Maybe you should listen.
Okay. So, that's an I. But guys, is the square root of 12 12?
No, I think about 4 times 3, right?
So, remember, square root of 12 is not what you want. You want a factor that is a what?
Whole number.
Perfect.
4 times 3.
Perfect. Perfect square. So, Vicari is saying 4 times 3. First off, Art, is one of those a perfect square? Yes. And is that the same as negative 12?
Yeah.
So remember, you want perfect square factors, and now you can rewrite it into these 3 factors. I need you to work on C, and then we're going to come back together and move on to the next skill. 2 minutes. Right? Yes, Mr. Kenny, I need a perfect square.
Yes.
Come on.
Yes, sir.
I don't know what Tyler did first, but I saw you, dog. Hey, y'all, we got one more really important thing we got to look at. I need eyes and ears here. So, when I look, I would probably write out my perfect squares. Write them out so that you can find. I'm sorry, am I talking?
Pretty sure.
To try to help you learn?
Pretty sure.
Thank you. So, write out your perfect squares and figure out if there is a perfect square factor. There's not always. Like if I look at 15, are any of these perfect squares a factor of 15?
No.
No.
No, not.
No, definitely not. So you don't have to do anything with that. But with 50, which of these is a perfect square factor?
25.
25.
Yes.
Notice negative 50 is 25 times 2 times negative 1. And so we simply rewrite it as these 3 radicals. So 5 plus, what's square root of 25?
5.
Is that a perfect square?
Yes.
No. No.
I can't see it.
2. Is 2 a perfect square?
No.
Is it one of these numbers?
Oh, yeah. 4, 2.
Which one?
That's what I'm saying. It's not.
Just 2, not 2 squared.
It's just the 2, one of these numbers.
No.
So it's not a perfect square, so I'm going to leave it as square root of 2, but what is the square root of negative 1? I. That's it. Okay? So find your factors that are perfect squares.
Okay.
Write down 1 or 2 of these as an example, make the notes you need to, and then we're going to move forward. This is page 104. There's also a prayer model for it. There's practice on Matthew. One of the most straightforward things ever, but I need your attention on this. How would I add these numbers together?
Add the 4 and odd.
Are those are both what type of number? Well, they're both imaginary, right? Like terms, but yeah, they're both imaginary, so I can put those together. What's 4i plus I? 5i. Okay. What's 3 minus 6? Negative 3 minus 1. So notice your reals go together and your imaginaries go together. That's it. However, I do want to point out this down here. How would I multiply these 2 complex numbers? You could FOIL, but remember, what have I recommended to help you distribute?
Oh, yeah, they're both.
The area model. You'll never hear me say FOIL. We're about to get into a unit where foiling does not work. So 5 plus 3i, 2 minus 3i. Notice, what's 2 times 5? What's 2 times 3i? Negative 3i times 5? Yes. Negative 3i times 3i. Now this is where I need you to pay attention. Close. Page 104. Well, first off, it's a negative times a positive, so it's a negative 9i squared. You didn't have the negative. Hey guys, I need you to pay attention to this, because this is an important detail that we have not talked about, but it's something that you already know that I'm built on. Listen, when you get I squared, you don't leave it as I squared. Because what is I squared? Alright, remember I was the square root of -1 because I squared is -1. So, -9 times, what did we say I squared was? -1, and a negative times a negative is a? Okay, so what's 10 plus 9?
19.
What's 6i minus 15i?
Oh, nah.
So, I need y'all to hear me clearly on this. Listen, do you leave I squared as I squared?
No.
I is fine, but make sure you rewrite I squared, remembering that I squared is equal to -1. So, -9i squared, that's -9 times -1, which is a positive 9. So, to multiply them, just use that area model to help you distribute. That is the last thing that is on your demonstrate understanding tomorrow. There will be solving quadratic equations with imaginary numbers. There will be graphing imaginary numbers, adding and subtracting, and classifying those complex numbers. That's what you're